What's up, everyone? It's Kyle here. Today, we're going to be covering something I feel new and existing developers should be looking at, and that is Spring Boot. With a great influx of Node.js devs out there in recent years, I'm seeing that there is a great supply and a lack of demand out there for the technology. Not saying that there aren't jobs out there for it, but when you're out there applying, you're going to have to fight hundreds of fellow Node.js devs for the same position every time you go and apply for a job. Things about learning back-end Java development is the global demand in the enterprise space. You will always hear about some kind of financial institution, manufacturer, or Fortune 500 company using Java to build out their systems because it is reliable and battle tested at the end of the day. There are many different use cases for Java in a business. May it be collecting big data, building the core infrastructure. So I know you want to get right into the action. So let's go ahead and start installing the Eclipse IDE and the Spring Tools set. So for installing the Eclipse IDE, we're going to go to Google and search the Eclipse IDE download. And then we're going to select the first one here, which is Eclipse download. Now, all you need to do on this page is click here where it says to download your version. Their site will determine which OS you're currently running, Windows, Mac, or Linux. So it doesn't particularly matter what you do here, except click this download button. Again, and download here as well. Now, for running Eclipse, you're going to have to be required to install a certain Java JDK version. As of right now, it is the minimum viable version is JDK 11, but in the future that will change at some point. So make sure that you install the proper JDK version, or else you can't install Eclipse. And then we're just going to open up the installer. Okay, with this installer open here, what we need to do exactly is install Eclipse IDE for enterprise Java development. Do not install Eclipse IDE for Java developers. That will only give you the standard development environment. We need the Java EE environment because that's what Spring runs in and has all the tools and such for it. Now we're going to install Java EE. Again, make sure you select the proper JDK version for install and wherever directory you're going to install this version of Eclipse. And then just click the install button. Again, agree to any licenses and such. And with that, installation process is complete, and then we're going to move on to the Spring Dev Tools, which will launch with Eclipse. Now here we're going to select our workspace that we're going to use. We're just going to use the default. Alright, so now that you have your Eclipse IDE installed correctly, what we're going to do next is start installing the Spring Tools set for Eclipse that enable us to easily create a Spring Boot project. So under the Help tab and then Eclipse Marketplace, we're going to click. I'm going to let this load. Now in this find search bar area, we're going to look for Spring Tools and then just hit go. And we're going to use the latest version of Spring Tools. So as of right now, it's Spring Tools 4. So we're just going to go and hit the install button. I already have it installed, so you go ahead and install yours. Now that you have your Spring Tools installed, I highly recommend that you go and restart Eclipse and reopen up the workspace in order to confirm that your Spring Tools has installed. And then with that, we're going to go over into create a project under this link here. We want to go and find the Spring Boot directory, and you want to click on the Spring Starter project, hit next, and here we're going to start the initial creation of our Spring Boot project. So here's where you're going to name your project, and then we're going to select whatever Java version you're using. And then you want to set the group name basically to whatever domain you're using. So either it's your organization or your own personal domain, whoever fits your situation. So my domain goes here. And then we want to name the artifact for our project. So probably just the same name as your project name. You can choose the version number of this project or whatever. This basically applies when you go and make a jar file out of your Spring Boot project to run. This will just be the name attached onto it. And then the description of our project, and then same as the group, we name the package, so the package structure. And then with all that, we're going to go select next. And here we start adding our Spring Boot dependencies. So for our current situation, to keep things simple, what we're going to do is go under the SQL tab, and then we're going to add JDBC API. No, not this. We're going to install Spring Data JPA, and then install H2 database. And then down in web, we're going to install Spring Web. And that's it for here. And then we're going to hit finish. And with that, it's going to load our project up with all its dependencies. Now, before running our project, what we're going to need to do is set the build path for our project. We're going to right click the project folder. We're going to then go to build path and then select configure build path. Then we're going to double click here. Make sure alternative JREs is selected. If you have no options in your dropdown, then you're going to go to install JREs and select whatever appropriate JRE you want to use. Apply and close. Make sure it's selected. Finish, apply and close. And with that, you should be able to run your Spring Boot project by going to right click on the project, run as Spring Boot app. And then in the console, you'll see that your Spring Boot app is running here on the Tomcat, built-in Tomcat server on 8080. If we go to our browser here and we go search localhost 8080, we'll get the classic Spring Boot white label error page, which identifies that the Spring Boot app project is running. So now that we have our Spring project up and running, at the very basic level at least, what we need to do now is define a package structure for our application to run basically in. It's going to help keep our code base organized and everything, and we know where everything needs to go. So under the source/main/java folder, we'll start having our packages for our application. Under the regular domain package, you'll have the main class that basically runs the Spring Boot application. What we're going to do is just right click on that package. We're going to select a new package, and then we're going to add a package called controllers. And then this is where we're going to be putting basically our HTTP endpoints. Then we're going to make a package for beans, where we're going to put our Java beans. So our object models, payload models, or whatever to model different types of data for our application. In the beans package, we're also going to add sub packages for payloads. And then a package for exceptions. And then our next package will be a configuration folder, basically, where we'll put our config files or property files to get from our application.properties file, which we'll cover up soon. And then a repository package. This will basically be where we put our Spring JPA files for searching and updating our data. And then finally, a services package that will be for our business logic in our application. So if we're running searches or anything and the exception handling around that, they'll all go into the services folder, those files. Now, I'm not going to cover every single thing Spring Boot has to offer, but I'm going to get you started so that you can start then exploring more yourself. What exactly we are going to do is build a simple REST API that will collect and give back data through Spring Web, a core dependency for our project. One of the great things about Spring Boot is the Hibernate ORM. It manages our SQL database tables for us. All we need to do is make a model class object that will map its variables for us and manage the creation and updates to the table. We want to keep our code base manageable for the future. One of the large parts of any code base is managing runtime exceptions and user validation. So later on, we're going to implement a system that will send standard formatted errors to our clients on each request that keeps the code base clean and easy to understand for the future. When starting up a Spring Boot project, you always want to think about how to structure your data first. When you have a solid plan for your data, at least in the beginning, you won't suffer headaches down the road when it comes to refactoring objects or whatever to fit your needs at that time. In the Spring framework, you model response objects using a regular Java class. Then that Java class is used to create SQL tables through Hibernate, the object relational mapper. Inside this Java class, we can include annotations that help the ORM when it comes to building or updating SQL tables. So we can define validation, primary, foreign keys, relationships, and whatever. But for this exercise, we're just going to cover simple validation of the object to get you started. Now, with the basics of our Spring Boot application all working now, let's go ahead and start building an object model to be used in our API. So right click one of the beans packages here and then make a new Java class. Make sure to remove the extension here and just be the beans package we're targeting. And we're going to make this a car model basically. So with our class created, we can go ahead and start inputting variables that we have for this data model. So we're going to make an ID to start off with. That's going to be the identifier for each individual car inside our database. We're going to specify then also a make, as well as a model and a year. Now we can't just go ahead and model this directly into the ORM. We're going to have to set up annotations for everything, as well as constructors and getters and setters. Now, obviously, we want to avoid having to write as much code as possible. So, and to avoid setting up the getters and setters ourselves, we're going to use a dependency called lombok, which is going to auto-generate the getters and setters and constructors for our object. So, if we go over here to the pom.xml file, and then in the dependencies list for our application, we'll go down here and add the dependency for lombok. So I'll just copy over the dependency. And of course, go ahead and copy that into your pom.xml file. Then you can exit out of it, right click your Spring application, go to Maven, and click Update Project. This will install the lombok dependency inside your application and rebuild the project. Now we can go ahead and start using lombok annotations. So we're going to add in all args, no args constructors that will auto-generate into our application. So we never have to update when we add a new variable. So go over here to the light bulb, and we're going to import from lombok. And to just add the getter setters automatically, we do @data. And of course, in Eclipse, you can just hover over the annotation and you get a brief description of what it does. Now with that done, we can look over here at our Java basically class outline panel, and we can see that it's made all the getters and setters for these variables within our model. Now, in order to start initializing our model inside the database, we need to confirm what is the ID for this class. So we're just going to add the annotation ID. Click on the little light bulb here, and then select JavaX persistence ID import. This will classify this variable underneath as the ID for the model. And we want to set how that ID is generated. So we're going to do it @generated value annotation. And then we're going to specify the generation type. Import the generate value. And this is spelt wrong. Import generation type. So this will just basically classify this as the entity that's auto-generated by the ORM. Now that we've defined an ID for our data model, we just need to provide one final annotation to describe to the Hibernate ORM that this is in fact the data model that we're using. So we're just going to say @entity, and this will define this class object as a data model that exists inside the database and carries on these provided annotations inside the class. With that, now we can go ahead and run our Spring Boot project again. Our Spring app is running back on port 8080. Now we go to localhost :8080/h2 console to bring up the h2 database login form. Now your password may be provided or you left it empty. Do whatever you'd provide in your application.properties file for the username and password. And then you can see that our car model was in fact made. It has an ID, a make, model, and year. You can just click on it here or type it in yourself and select from that table and see that this table exists. Hey guys, so I'm just coming back from the future a bit here to deal with the validation for our car model first. So when we're validating our car model, we're going to be checking the fields within inside of it that meet the constraints that we're going to put on them using annotations here. So to get started with that, we're going to import a package in our dependencies pom.xml here, and we're just going to copy paste this here. We're going to be using the javax.validation package. So you can either use this version or another version. Find out what works best for you at that moment and time as you're viewing. All right, so we're going to close this up And we're going to quickly just right click, run as, save and install, so we can reinstall those packages in our dependencies list to confirm that they're there. And with that, successful. So here I'm going to start adding our annotations. So for the make field here, we're going to just add a not null and a size annotation. Now import from JavaX validation. So what not null is basically going to do, if you know SQL, it's going to be defining that column of the table as not null. So you can't provide an empty string or a null for the make field in this situation. And then the size, we're going to be saying the string must be between 1 and 25 characters. If it's 26 characters, we're going to reject that car model that's coming in on our endpoint in like the post, delete, or put body. All right, and then here we're just going to do the same thing for the model of the vehicle. And then we're going to add annotations for min-max of the year. We'll import these. So now the year can only be between 1950 and 2030. All right, so we're going to quickly here build the project again to confirm that everything's all right with this. Everything looks good, so that's fine. So now we're going to move forward and starting to use sample data for our project in a bit. All right, guys, so now we want to start injecting sample data into our H2 database in a super easy way that we can modify no matter the situation. So here we're going to create a file which is called a data.sql file inside our resources folder here. All right, right click, make a new file, data.sql. Now the name has to be data.sql because that's what Spring recognizes for the injection file. So here I'm going to add basically a working insert statement for our car model. So when I basically shut down the project and I restart the project, quickly save, this should insert the data for us. So it runs properly. I'm going to go into Chrome here. I'm going to localhost 8080 H2 console, open this up, and then select the car model, and boom, it is there. Now, to check that our validations are kind of working here is we're going to try to make an exception pop up for one of them. So we're going to target year in this case. So here we set it in the car model to be only between 1950 and 2030. So what happens if I turn this into 2050? I'll save that. I'll just refresh the project. And this should cause us to have the Spring Boot application crash. With some type of data model made inside of a SQL database, we can start performing CRUD operations on the data. To do that simplistically with all the management taken off us, we use JPA Repositories. What JPA does is provide an easy-to-use interface to query and manipulate objects stored in our relational database system. On the right are examples of JPA methods to select, insert, update, and delete data from object tables. JPA can perform CRUD operations on sub-objects as well and maintains atomicity with behind-the-scenes commits and rollbacks to keep data consistent. If JPA methods don't fully cover what you need exactly for your queries, you can always fall back to the custom queries and run that through JPA's interface to get the job done at the end of the day. To implement a JPA repository for our car model, what we're going to do here is go and right click the repositories package and make a new interface. Now, before we create the interface, we're going to add sort of an extension to this interface of methods that we're going to use. So we're going to search CRUD, and we're going to select the CRUD repository here. Click OK. It's been added, and we're going to call this interface car repository. Finish. Now here it's going to auto-generate the code for us, and we're going to define this type as a car. And then what the ID of the car type is an integer. So I'm just going to hover this, import the car model. Now here we're going to specify this as a public car, and we're going to name this find by ID, and we're going to say it's int ID. Now you need to be particular here when naming your method. It must be find by always, and then following the find by is the field that you're looking for. In this case, we're looking for the ID field of the car model. So then in the parameters for this method, we're going to specify the ID. This is in camel case here, so always start off small and then go large. Say you have a word and then followed by another word like first name. So it would be, in this case, first name. But in this sense, we're doing the ID, so we don't need to do that. All right, so we save that, and now we can go and search our car model. Our business logic for an API, we need to handle points of failure and deal with user mistakes. In order to keep our code base clean and maintainable with rising complexity and all, we need to build a runtime trigger system for exceptions that take place in our code. This will help us keep things simple and replicatable. We would also want something to automatically respond to the client with any appropriate message we need to send. So we're going to leverage Spring Boot's functionality to do all of this for us. Before we can go ahead with the creation of our business logic inside of our application, we need to first cover an exception model that we can use to take care of exceptions inside of our application. So say we're requesting a database for a query or something, and the database might be down or there's something problematic with it, and we need some kind of model to respond to that database exception and then return some kind of model JSON to the client so they can understand what's going on. So to start with that, we're going to create a trigger model of exception for our application. So what we're going to do is extend a runtime exception class, and we're going to go to the exceptions folder inside of beans, and we're going to create a class here. We're going to name it API request exception. Click finish, and here it's going to extend runtime exception. Now we have this model very bare bones, just the class itself. We're going to add some data to this, which is going to help us when we're passing it from the business logic to a sort of an event-based trigger for every time this exception is thrown. So private HTTP status. So this is going to be our status code basically that we're passing as when the event gets triggered, which equals HTTP status dot internal server error. So we're going to set this as a default here. in case we do not provide it at all, but we want to provide it most of the time. Then we're going to make a variable, which is a hash map, basically, of any validations that fail on a request, per se. So if I pass a model object to the service that I'm trying to do a post, update, or delete request with, it's going to do the initial validation of the model to confirm the variables are correct. And if they are, this won't be filled in, but if it's incorrect, then there will be some key value pairs stored in this hash map to tell what's going on. Again, we're just going to provide a default, which is a blank hash map. And then here we want to create basically a timestamp for this request. So we're just going to make it an epoch time, which is just basically a long value that can be used to be transformed to any different type of time zone or whatever. So it keeps it quite standard across the board, and then you can choose what to do with that epoch time yourself. So here we have our variables that are going to be defaulted if it's not filled in, and we're going to apply lombok here to get getters and setters for us. So it's super easy to make. So we're going to import at data. As well, we're going to just import the constructors as well. All right, now this is giving us some warnings. Just confirm everything's all right. It's asking for just a default serial ID, so we'll just provide it as an auto-generated option. This won't have any issues for us. All right, so with this now, we need to create basically a response object that we will send to the client, because when we're responding with this model, it's actually going to keep the runtime exception data with it as well when we're sending it as a response. So we just want the data that would be in this exception sent. We don't need the extra stuff from the parent class here. So we're just going to make a model for it. So in our payloads package here, we're just going to make a new class. And we're going to call it API error response. And then here we're going to say private string message, which is the message you would make for the exception. Here we're going to do private HTTP status. Again, just copy the things over. Import the hash map. Now here, since we're going to be using a builder method in order to build this up without having to do each and every getter, well, each and every setter, we're going to use @builder which comes with lombok, which basically allows us to do it all in one kind of method call in a clean way. At least we'll show that coming up. We need to provide the getters and setters as well for this, for the builder to work. Going at data, and an all args constructor. And for the builder here, in order to set the defaults, we need to annotate these with builder.default. Now that we have our runtime exception and exception model made, now we need to create the event listener basically for when the runtime exception is thrown. So then we can fill that into the data model and then send it as a response to the client when there's an exception. So in order to do that now, we're going to right click the controller package and create a new class. We're going to call this exception handler controller. Click finish. Here we're going to add an annotation that is at controller advice. And what at controller advice is basically going to do is watch for any exceptions thrown that are specified inside this class. So in order to do that, we're going to specify another annotation inside of this class, and it's going to be exception handler, and we're going to specify the API request exception we just made. Now we need to provide some kind of method it's going to be following up on, and it's going to call this response entity as the response object, and the name of this is just going to be handle API request exception. Now quickly we're just going to import exception handler. Here we're going to make sure to specify this as a dot class. And we're going to import response entity. Now the parameter that's being passed here is just the exception. So it's going to be an API exception, request exception. And we're just going to call it exception. And then here is our body for our code. Now down here we're going to say return new response entity, and it's going to have a response object, and there's going to be an exception dot get HTTP status. So this HTTP status that we had in the model over here is going to be used when setting the status code for this response. Close that out. Here now we're going to make a API error response. Call it response API error response. You don't need to say new here when we're using the builder. So builder. And then we're going to provide a dot message. So then it's going to be the exception dot get message, the dot timestamp, exception dot get timestamp, HTTP status, exception dot HTTP status, dot build then. So this is gonna round it out and build this object with these variables set into the variables inside the class. And with that, now when we throw the API request exception in our business logic, what the controller, like the main controller, would do here is basically forward it to this, and the code in here gets ran and then returns this to the client instead of just getting an empty error per se. So I went ahead and added another exception event trigger for our handler system. So here I'm basically triggering an event based upon the exception of method argument not valid exception. So that basically gets triggered whenever a bad model object comes in on a post, put, or delete request to our API. And that's triggered based upon the annotations we had inside the bean for the car model. So one of the things that takes place here is we have this exception model of the exception trigger, and then we're taking out basically all the error-prone fields that were in that object model right there. And so here we're creating a hash map out of those different problematic fields and just looping through the error to get all of them. And then we're just stuffing them inside our API error response model that we're going to send to the client. And here we're just using bad request because there was bad data sent. And then a simple message we put here and just say payload validation failed, build it out, and get sent. All right, so next we're going to go in here and basically create a new file in the services package, and we're going to call this car service. And in this file, we're basically going to have all our business logic for catching any like car we want to find or creating a car object and so on and so forth, updates, deletes, wherever you want to add to this. So here, to define this as a service inside of Spring Boot, we're going to call it the annotation above the class and then just service. We're going to import that. Now, with this class, what we're going to do is perform some dependency injection. And basically all that is just providing another object inside of this file here. So we're going to be importing the JPA repository. And because of us adding that into the class, it's then bringing in a dependency for this object itself. So here I'm going to say @autowired, and then we're going to call in the car repository, and we're just going to name the variable car repo. Put that, and import that as well. And then next thing is we're going to make a function that's going to search the database for a car by its ID. So here we're going to say public car get car by ID. I'm going to int the car ID as a parameter for this. Make that function. Now we're going to have a variable called searched car, and by default it's just going to be null. Make sure to import this car model. And then we're going to return the searched car. Take that. Now, in between, basically, before it's null and it gets sent as the response, basically, we're going to say a try catch here because we're going to make a database connection. And we're going to catch. Here, we're just going to be very generic and just catch any exception that gets thrown in the process. And here we're going to have the searched car equal the car repo, is where we're using JPA Repositories, dot find by ID, the one we defined. And then here we're just going to say car ID as the parameter. Why is this? Oh yeah, searched. All right, fix that. All right, and here we would basically throw an exception. Now, before we go ahead and just jump into throwing whatever exception we want, we're just going to make it super clean for us here. And below here, we're just going to have our exception functions. Well, in Java, it's methods, so methods. And basically, we're just going to make the exception defined basically as a function for us to call upon. So we keep the actual business logic clean. So here, we're just going to say public API request exception. So the one we created. And we're just going to call it error. And then connection to database failed. Right? And we're going to define this. We'll call it exception equals new API request exception. And here we're going to provide the message for the runtime exception. Make sure to import this real quick. And we're just going to say connection failed to data source. What is this? All right, to quickly solve this error that's taking place here, I forgot to add in a constructor method for just the message inside the API request exception class model we have. So I'm just going to open up that file real quick here and just say public API request exception. And then we're going to pass in just the message here. And we're going to say super message. Save that. Now over here, this will fix itself. And as a result, we can just return the exception class. But before we do that, we're going to add in some more variables to this. So the exception dot set the HTTP status is going to be dot internal server error, and the exception dot set, in this case we don't need validation messages, so we can just use the HTTP status code here and then return it through this method. So now we go up to here where we have the try catch, and all we're going to do here is say throw and then the function name. And there, it's set up for us. And we just have to help clarify things here and say that this is going to throw an API request exception. Oh, throws. All right, and there, that enables us now to basically select from the database and collect ourselves a car object based upon that ID, and then return it over to the endpoint, where then we can just do some network traffic things. One thing we're going to do to just quickly fix up this select function here is basically we're going to add a method, well, not a method, we're just going to add an if statement to basically check and see if there is a null object response from the database. for the car, so then we can send the appropriate response for a 404. So here we're just going to say searched car. If it equals null, I'm just going to throw a new exception. So what would we call this? Error car not found. Okay, so we're just going to go down here, basically copy this exception style. Going to change this to could not find car. And then change this to a not found. And the title of this. Error car not found. Alright, that'll cover that situation there. Now it's time to add basically the insert method for our database here. So we're going to be returning a car object, as it'll be the newly inserted response with the correct IDs and everything. We're going to say the method is called insert car, and then we're going to have car, this car, throws API request exception, and we're going to go about copying this code here. So we're going to definitely copy the try catch. And I'm going to call this car new car equals null to start off. New car is going to be made here. I'm going to say dot save. This is done for us already by JPA. So we're going to save the car we got. And if there's an exception, I guess, thrown, we're just going to say internal service error, server error, and we're going to return the car, well, the new car variable. Now, before we can go ahead and just finalize this, we're going to also have the car.set ID equal to 0 automatically. And this is to prevent any like ID being sent by mistake, because this is a new car after all, and we're inserting it using the auto increment. Now with our business logic created, we can start implementing the basically endpoints that we want to use here. So first things first is we have to implement the service. So here is just some dependency injection using the auto wired annotation and saying private car service, and we're just going to call it car service import. All right, and then down here we're going to say car service dot get car by ID, and then make sure it passes the car ID. And then here in the post request endpoint, we're going to just say car service dot insert car. We're going to save that. We're going to run our Spring Boot instance. Make sure it boots just fine. Then here we're going to open up a Postman client, or you can use your browser, and we're just going to send a request to our backend now. So localhost 8080/car, and here we're just going to get a car, so ID 1. And then you don't need a body or anything here, and we're just going to send a request. And there's our car model right there when we search for car ID 1. Now, if we search car ID 2, we should get a 404 error that we standardized. The car not found. and then request is a 404 status here. Then we open up a new tab. We're going to do a post request, localhost /80/car. Here we're going to say quickly grab a JSON model of it. In the post request, we're going to do headers real quick and then say content type, then application JSON. In the body, we're going to make it raw, and we're going to basically have this format here. Now, we're going to say ID1 here just to make sure that it won't cause any upsets, because we set in our business logic to set it to 0 always, and then the ORM will pick what ID it will be. And then here, we're just going to change this to Honda, and the model is going to be Civic. And we're going to make it a 2015. Now this should go through just fine. And see there, the ID is set to 2 here, so automatically perform for us. And then we have a Honda Civic object created inside of our database. So now that we have our API functioning with a get and post request, now we need to tackle basically adding a wrapper around the data that we respond to the client with. This allows us to provide some metadata about our API, such as version numbers, which we're going to perform in this. So the first thing we're going to do here is basically add a property into our application.properties file. So we're going to label this as API, and then dot version number, and then that's just going to equal 1.0.0. All right, so we're going to close that, and then we're going to basically have a configuration class file that's going to allow us to import that property variable inside of our Spring Boot application to use it. So here we're just going to call it API properties. And then in here, we're going to define lomboks at data, and as well as define this as a component inside of Spring Boot. So then we can utilize it on imports into other classes, live services. So import those two. And next, we're going to have to define an annotation that's going to basically enable us to grab whatever certain keyword we're looking for on the properties file. So here we're going to look at API. So we're going to do at configuration properties, and then set it to API. So this will only look at basically properties tagged initially with API at the front. Now here we're going to say private string and then version number. Now make sure this variable name matches the one in the application.properties file here, so there's no conflict whatsoever, and it'll be the right variable when you get it. Make sure that's saved. And now here we're going to basically go into our beans/payloads package here, and we're going to add a new class, and this is just going to be like a wrapper model that we're going to use for when we send our data out. So here we're just going to call it response wrap. And in it, we're going to define a string, and that's going to be the version, and another string, which is going to be a bare bones object because we don't know what object we're going to send in this response. Because we could have a car model, we could have some other type of object like a person object or whatever, or a user object. And we're just going to call it data. Okay, and then we're going to define a builder annotation and a data annotation to help us construct it. Make sure they're imported. Next thing we're going to do here is then go into the controllers package and we're going to make a new class. And we're going to call this response wrapper. And here it's going to implement a interface called response body advice. And import that. Oh, is that spelled wrong? Hold on, let me copy. Okay, there. Import that. And then we're going to do an annotation to define basically where this class basically looks at when it comes to the controllers that it's going to be wrapping. So here we're going to define an annotation for controller advice. And we're going to say inside of it, base packages equals then the package path for that. So here it's going to be code.scuffdesign. Dot controllers. Let's save that. Also import the annotation. And here we need to start implementing basically the required methods of inside this. So I'm just going to copy paste from my example. First we're going to add this. So the media types are going to be supported. Then make sure it's Spring Core. And then here we're going to have a method that's going to override basically the interface we implemented. It's going to be an object, and then the name of this method is body, right? And then here it's going to implement a few parameters. Make sure you import all these types. Spring Framework HTTP. And then it's going to be the Spring HTTP server. Same thing here. And it needs to return a body. So here we're just going to say return a body. Make sure these are correct at the top actually. Implementing service before write cannot reduce visibility. Oh yes, here. I messed up actually. Okay, we're going to be a public object. There, fix the error. And here we're going to basically say if the body instance of an object, so just any object that we throw out of as the response, we're going to perform this action inside. So response wrap, so our wrapper model class, wrapper equals response wrap.build. So we're just going to do a builder for this. So dot version is going to be basically implementing our API properties component that we made earlier. So before we can do that, we have to auto wire it in. So private API properties. I'm going to say API properties. Import it. Now here we're going to say API properties dot get version number. And then we're just going to say the data is going to be the body from the response that we're sending out. So basically before body write is the event listener basically at this point, where when we send a response from the endpoint, it's going to take that data that we're responding with at that state, and we're going to basically create a wrapper for everything and return it. Right, so then we're going to build, and then here we're going to return the wrapper instead of the body. Now theoretically then how this will work is wherever we just send an object out of our API, it's going to just use the wrapper instead of the regular old body. So that even goes for exceptions. So if we throw an exception, it's just treated as an object. So it will be wrapped as well, same as a proper response. All right, we're going to save that. And now we're going to run the Spring Boot project. And hopefully there's no errors that we need to correct. Looks good. So now we're going to go over here to Postman. And we're just going to use the examples that we did before. So we're just going to get a car of 1. And there we go. We have the version number now wrapping our data. So now let's get an error response. So we just go with car of 2. And you see the version number also is there, and it's wrapped over our error is basically in this data field here. So now we have a response wrapper for all of our responses inside our API. So that helps clients or fellow developers know what version of the API is currently being used at this time. And with that, that basically concludes the Spring Boot Quick Start Guide. I'd like to thank everyone for watching and paying attention, getting through this, and hopefully you became a better Java developer at the end of the day, and you could start building enterprise-based applications at scale when you do a little bit more research, figure out what databases to use, do some more configuration with Spring Boot to get things to work how you want it, and so on and so forth. Now, make sure to like, comment, follow, or subscribe where platform you're on. I hope you enjoyed the video. I'll see you again next time.